white band. It's actually pia going from the cord to the dura. We have another one here. Sort of hard to pick out, but there's a good one right there for a denticulate ligament. Teeth-like ligament. Those can be broken with pretty good trauma, we'll say falls or car accidents. Whereas the other one is down in between the fibers of the cauda equina. Stabilize your conus inside the spinal canal. So we have to tease apart the cauda equina and now see this massive thickness of pia goes all the way down to your coccyx, anchoring the conus inside the spinal canal. Keeps it from flopping around. Very unstable if this would be broken. Never heard of one really being broken without the person being killed by some other trauma, some other damage, skull fracture, or massive internal injury. So rarely do you hear anything about the filum terminale. It's a great stabilizer for the conus. And then you can see a little pia teased off the cord there. Angel hair, delicate layer. So those are the structures that are really very important to the clinician. Conus, cauda equina, denticulates. You don't really see very much here. And filum terminale. Here the brisk. In the UK, it's phylum terminale. Irritating. But phylum is filum. F-I-L-U. They have some strange pronunciations. You know what sonometers are? In the UK, they call them sonometers. They're centimeters. Or vitamins. Or vitamins. I just heard one say it's cervical. What's cervical? Cervical. The neck. It's almost like a foreign language. They show up at Hershey all the time for fellowships and seminars. It's like, what language are they speaking? I thought they were English. Odd pronunciations. Now you've got your neurohistology with the all-star cell, gigantic neurons. So well noted from the cell body with the protoplasmic extensions coming out of the cell body. You see dendrites, but one axon. So these would be mostly all the dendrites, but somewhere in here would be an axon. But for this preparation, there's no way you can tell the difference. It's just a nice big CNS neuron. Outside of it, you get this kind of fibrous look, the scaffolding cells, neuropil, or for lecture, you hear glia, or neuroglia. And generally you say, well, 90% of the cellularity is neuropil, supporting cells, 10% neurons, the impulse conducting cells, the communicators. So I always like you to be able to at least see where the axon should be, a special staining technique, use a Nissl stain, gives a granular look to the neuron, it's actually RER, it's an organelle that stains with it, and that we find RER in the cell body and the dendrites, but never in the axon. So it's a good technique to find the axon where you don't find the Nissl. So you look around, you know, there, it's there, it's there, it's here, but here, this is the axon of that neuron. These are the dendrites. And you also get a good look at the nuclei of the neuropil all around the glia, holding it in position. I would ask you, which one is the axon? This one on to this side. And then you tell the difference between cerebrum versus cerebellum. Texturally, quite easy, but the cerebrum, big, large, thick gyri, very wide, expansive sulci. Easy to see the pia, the wispy, delicate inside membrane of the meninges right there. Goes all the way down into the sulcus. Always tells you you're on the outside. So when it started, it was all on the surface, and then it infolded. The pia went along with it. So even down deep in the sulcus, you see the pia. Whenever you see it, then this is the gray layer, the outside layer, all the way around. And then the white inside. Neurohistology, if it's white, it's not white matter. Common mistake, always stains with some kind of color. This is the core of white matter, gray matter on the outside. And then you look at the texture of the cerebellum, everything's more compressed. Just what you would expect from the gross anatomy. Much smaller, thinner gyri and tiny hair thin sulci. Texturally, no one really has trouble with cerebellum versus cerebrum. And then even the sulcus is white, it's a space, versus the white matter, which is inside, in the cerebellum, arbor vitae. Trunk of a tree, a limb, and then a little twig inside each of the gyri. So then go back to cerebrum, high magnification in between two gyri. Here's your sulcus, great look at the pia, highly vascular, fresh specimen, it looks pink because of all the blood vessels. And then you have the cerebral gray, 6 layers to the cerebral gray for humans. You just need to know the name of the first and the last. Always next to the pia on the outside, molecular layer. And then the deepest, next to the white matter on the inside, multiform layer. And then the 4 in between. You don't have to know the GPs, the granulars and the granules. Just molecular, and then multiform. And then a little more magnified on the cerebral gray, where you see these great neurons, pyramidals as we call them. I sort of like you to see them with just seeing the dendrites heading up to the molecular, and these tails are the axons heading for the white matter. We like to say generally dendrites go up, axons go down. Physiological direction for how these are structured in the cerebral gray matter. That's just sort of a curiosity. We have this kind of alignment for those gigantic neurons. This is actually where all your voluntary impulses begin. So when you decide to get up and leave, this is where it starts. Yep, I want to get out of here. Then it goes to the white matter, off to to the cerebellum for coordination, and then down your corticospinals and your spinal cord, getting your muscles to move. Rather elaborate process. Amazing how smooth it works. And then higher mag for cerebellum. The key is always this layer. Whenever you see this, granular looking, it's gotta be cerebellum. Doesn't look like that, it's a layer in cerebrum. And then in cerebellum, you have 3 layers of the gray. So start out in the sulcus. Right there. The first layer, quite thick, molecular, same name as the cerebrum. The second layer is 1 cell thick. Those are your Purkinjes. And then the third layer is the granular. Underneath, white matter, part of the arbor vitae, and then out the other side to the next sulcus. We can do a little more magnification right here. Get a good look at those Purkinjes. So here's the edge of the sulcus. Molecular, first layer. Gigantic neurons in between for Purkinje cells, the great coordinators. Granular layer underneath, and then the edge of the white matter on your right there. The granular always sticks out for high mag identification for cerebellum. That's the one you really look for. And then the very special preparation for Purkinje, silver stain showing this beautiful flash-shaped neurons. And then you look at the molecular side and massive dendritic branches, some upwards of 200,000 dendritic branches coming off the Purkinje cell body. Amazing neurons. Just in between the molecular and the granular layer. White underneath. And then you got your peripheral nerve histology, where you're going to the outside covering. What is epineurium, corresponds to the dura of the meninges, tough, strong outer layer. It's the only reason you don't pop your nerves every time you extend your fingers or your arms. The epineurium holds them together. And then on the interior, it looks like a honeycomb structure. These perineurial compartments, much thinner, much more fragile for those. And then inside each compartment, you have thousands of nerve fibers. It's like an old phone cable. And then if you stain it just right, you can get a lot of these dark rings, which is actually myelin stained black. So we like to take a little area, kick it up 200 more times. We can actually see the axons, the nerve fibers going to and fro in a peripheral nerve. They just sort of collapse as a little dot of tissue. And then what really stands out is the outer myelin coating, the dark rings. You say, well, outside of those rings, you have a little puffy tissue. Sort of cushions all of your nerve fibers. Now you have endoneurium. So you have epi, peri, and now endoneurium, which is actually laid down by these cells, neurofibroblasts. Don't have to know them, but they're just obvious on the exterior. Often confused with the cells that make the myelin, which they have nothing to do with. Where